Welcome once again to your lecture in inorganic chemistry. For this meeting, we are going to discuss a new topic regarding still the elements which are found in your periodic table. So we are going to discuss this time the transition metals and sometimes we call this as coordination chemistry. So if we're going to look at the periodic table, you have here what we call the transition line. And the elements found here are your transition metals. So this is your periodic table showing to you where are the transition metals. So based from the periodic table, you have here the different uh, transition elements, which are usually also metals in nature. Transition metals show great similarities with a given period as well as the given vertical group. So what you have learned as the characteristics of the zinc group and also likewise the yttrium group follows as the same with its vertical group and also with its given period. So let us try to review the forming of ionic compounds. Transition metals generally exhibit more than one oxidation state. So meaning to say, not like for the case of hydrogen, that hydrogen has only one oxidation state that is plus one, and oxygen plus two. But for the case of iron, it has plus two or plus three. Cations are often complex ion species where transition metals is surrounded by a certain number of ligands. Please recall your Lewis uh, concepts that you have taken when you were in your elementary days or grade school days. So you might uh, be so familiar with your Lewis formula. This is the complex ion of cobalt. So here is your cobalt. The cobalt has an oxidation number of what? Please refer to your periodic table. Now the cobalt could be bonded with any compound. In this case, what is illustrated is yung amine group or the ammonia group. So the cobalt here is actually bonded with 6 NH3. So you have there 1, 2, 3, 4, 5, 6. So if we're going to look at, this is actually the center and it is illustrated here as the red uh, ball in the or molecule in the model. And then you have here the nitrogen and you have here the hydrogen. So if you want to look into the molecular structure using the molecular model, this is how it looks like. But if you're going to look at its geometrical structure, well, this is how the hexaamine cobalt looks like. So why the name hexaamine cobalt? Hexa for the 6 ammonia or the hexaamine, amine, NH3. And then you have there the cobalt. For complex ion like this, the cobalt or the metal is the one at the tail of the formula. Aside from the ruling that it should be alphabetically arranged. Okay, so you have there the ion hexaamine cobalt with a charge of plus 3. How to determine the plus 3? It involves a lot of mechanical illustration or chemical illustration. Ionic compounds with transition metals, most of which are colored because transition metal elements in the complex ion can absorb light. But the kind of color or the type of color depends upon the specific wavelengths. Actually, most of the gemstones that is sold in the market, which are in the form of crystals, but not actually crystals for some metals, the one that gives the color are are your transition metals. With these characteristics, being a compound or an ion that absorbs light, it is also called paramagnetic. It absorbs a certain amount or attracts a certain amount of light or specific within a specific wavelength. In terms of electron configuration, you have here some examples showing to you that there are some roles to follow also. For the first row transition elements, the first row transition metal ions do not have 4s electrons. Usually, they have the 3d orbitals or they have the 4s orbitals, except for the case of chromium and Cu. So for this illustration, you could have here the 3d3 and the 3d6. So they follow the 3d orbital rolling. That is for the case of the first row transition elements. Always remember that. And then if you're going to plot these things, you have here the red dots and the blue dots. So lots of the first and the third ionization energy of the first row transition metals could be illustrated here. So you have here the first row transition metals, and this is their first ionization energy, and this is their third ionization energy, whereby their valences could be lifted with. In terms of atomic radius, you have here the first series, the elements here. No? You have here the first series. By the way, I'm gonna give you, or I'm gonna post profile to give you time to bring out your periodic table or your paper and also likewise a pencil. During normal cases, I usually expect my student to bring out their periodic table, paper, and ball pen whenever they enter my classroom. I forgot you are in your virtual class. Please, if you are in your Chem 1, in Organic Chem, Analytical Chem, always have with you your periodic table because the periodic table serves as the reference or the cover of all your reference material. So I assume that you have your periodic table now. So you have here the first series of transition metal, and the blue one is the second transition series, and the red one is the third series. And then based in your periodic table, the the first series has the 3D trans, distribution of elements. And then for the second series, you have 4D, refer to your periodic table. And then for lanthanum and the rest, they have the 5D. In some periodic tables, you have already there the assigned last distribution of electron configuration. So, as we have made mention, most of them have the 3D orbitals. So, if you're going to look at the first series is 3D, the second series is 4D, the 5 series is 5D. Okay? So, what can you see from the graph? In their vertical position, as you go to the right, their atomic number is decreasing. So, as the atomic radius increases, or based from the atomic radii uh, presented in the periodic table, the atomic number also decreases in bursts. Now let us start to look into the 3D transition metals or the first series of your transition metals. Is cadmium. If we say chemistry, we are referring to the chemical characteristics or its nature and its chemical property. So is cadmium, Sc, chemistry of cadmium strongly resembles that of the lanthanides. Again, review your periodic table. If you're going to look at your periodic table, may I go back to my slides? You can see here the lanthanides and you can see here the actinides. So these are your, if this is the whole periodic table, actually this is already complete, no? These are your lanthanides and these are your actinides. And these are the different elements found in the lanthanide series and these are the actinide series. So this is cadmium has a chemical property that are the same with these kinds of elements. So that is your cadmium. However, there is still some other properties of the 3D series. You have the titanium. They are very, very light in weight. Hence, they are excellent structural materials, especially for vehicles or fast-moving objects that do not require a lot of weight in order to have a great mobility. You have also vanadium, but the vanadium are usually used as an alloy, meaning to say they are mixed with other metals. And most of the time they are also being extracted in not in a pure form vanadium. And then for the case of chromium, chromium is usually used for important industrial material. Manganese, it is used in the hardening of steel. Iron, I'm sure you have seen iron. Iron is everywhere, no? Um, that does not include the medicine that you are using, the one in the blood. Well, that is still part of chemistry of blood. Um, Iron is the most abundant heavy metal. Cobalt alloys with other metals. Then nickel plating, I'm sure some gentlemen knows this. Uh, these are nickel plating is the one responsible in the aluminum like or silvery like finishing of the back of tricycles, the body of tricycles that now it is banned because it is a very because of its reflective property to light. Uh, in some cases, we call this nicolado. When the owner jeepney is very popular, most of the metals, most of the tube metals used in its body, they subject this to what we call as nicolado, but that is actually nickel plating. Copper, I'm sure you know what is copper. It is now responsible for the modernization or to the very advanced technology of our world now, because copper is the most popular um, transmitter of our electricity, being a very good conductor. uh, it is used widely from the smallest gadget that we have to the biggest appliance that says that we have. You can see copper. Then zinc, you can see this in your rooftop. It is your galvanized steel. The reason why your rooftop is similar to the color of silver is because of the zinc present. And then here are some illustrations as to what are the oxidation states and the aqueous solution. But what you are going to look into here is first, the vanadium has an oxidation state of plus 5, 4, 3, 2, 1. Sorry. 5, 4, 3, 2. They are all vanadium, but if they are in their aqueous solution state, they come in with different beautiful colors. So vanadium in its aqueous solution is yellow in color, plus 4 vanadium is blue, and then plus 3 vanadium, uh, it is blue-green, but this is already in its very aqueous state, and then violet for the case of plus 2. You should know these things. By the way, class, if I say you should know tendencies is I give this as part of your quiz. Okay, so you better mark this now. Now let's go to chromium. Chromium plus 2, chromium plus 3, chromium plus 6. If the vanadium works with the oxygen to become its aqueous solution, this chromium works with halogen. Again, review of your basic chemistry. There's if we say X, do not look for X in your periodic table. X means the halogen, the whole of that line of halogen. May I move myself here so that we could see eye to eye. If you move your periodic table in the halides group FClBri, can you see that in your periodic table? These are your halogens. The chromium, the chromium are very attracted to the halogens. The FClBri80, that is the second most extreme right of your periodic table if you have not yet seen that. You memorize that also because your your knowledge on halogens will be again needed in your next chemistry subject, the organic chem. It will be again needed in your biochem. It will be again needed in your analytical chemistry. So it's very easy to memorize. FClBri80. All of these are your halogens or halides, by which chromium is very attracted with. Now, in terms of color, it does not mean that it is colorless here. It depends upon the halogen that they are working with. But chromium plus 3 working with oxygen, the color is green. For hydroxide, blue-green. Now for chromium plus 3, working as your potassium chromate, the color is orange. It adapts the color of potassium, by which the potassium are usually orange to dark. It ranges from light yellow to orange brown in color. And then if chromium plus 6 is working with the metal sodium, the color is yellow. And chromium plus 6 working alone with oxygen, the color is red. Okay. Now let us try to look into manganese. You have manganese plus 2, manganese plus 4, manganese plus 7. The most lovable of them all is the manganese plus 2. Manganese plus 2 in its hydroxide form is pink in color. This is a very beautiful pink. You could usually see this pink in some gemstone. And then you have also manganese sulfate. It is pink orange or salmon in color. And then you have also manganese sulfate. It has this reddish tint color, but it's not pink. It is more on the reddish side. It is not even fuchsia. It is more red than fuchsia. So if you're going to notice, manganese plus 2 includes this manganese chloride or with working with halogen. Their color goes with the shade of red for the plus 2. Pink is within the shade of red. This is orange pink, red pink. So they carry the hue of red. But with the manganese plus 4, its color is dark brown with oxygen. And then for manganese plus 7, it is purple with the metal potassium. Okay, we have here iron. Iron plus 2, iron plus 3. For the case of iron plus 2, its color varies. So if it is working with oxygen, ferrous oxide, it is black in color. Ferrous sulfate, ferrous sulfide, sorry. Ferrous sulfide, brown is black. Ferrous sulfate, green. For plus 3, with any halide, brown is black. With oxygen, red is brown. And then with metal, potassium, ferricyanide, it is red. And both plus 2 and plus 3, you have red in color. And then for double, potassium, ferrocyanide, it is deep blue or Prussian blue in color. So I'm gonna give you a hint or a tip for your quizzes or exam. Usually, what is written here is of course number 1, 2, 3, 4, 5, 6, and then written here are the different metals with their oxidation numbers. Second column, of course, you have to fill this or you fill this up. Or maybe the black color is present or stated. The compound is also stated, but you're going to give and what to supply is the element and its oxidation number. So you might be given a table and the direction could mean complete the table. So either two of these are given or this is not given. So you are going to supply what is not given. Okay? So you should know the oxidation state of the metal combining with another element to form a certain compound, and what is the color of such compound. Okay, we have here cobalt. Cobalt is another beautiful metal. So cobalt plus 2. So if we're going to look at the color, dark blue persulfate. If it is working with halides, they are pink, chlorine. And then if they are working with nitrates, they are red. Sulfur, black. Oxygen, green. Now for plus 3, with metals, usually they are brown. And usually their favorite, uh, kindly correct, this is actually a halide. You could have X if you want. So usually cobalt with halides are brown in color. With oxygen, uh, it is not really that black. It is lighter than black. And then with cyanide, cobalt in its cyanide form together with metals are yellow in color. And then cobalt with amino. I think you know already the name, how to read this name. The color is also yellow. There is no similar characteristics between and among the color of cobalt. They vary. And then for the case of nickel, they give the hue of yellow and blue. So for nickel bonded with halides like chlorine will give you yellow, and then in its aqueous form bonded with halide, it gives green. With oxygen, green is black. With sulfur, black. And then with sulfate, it is green. Then for nitrites, it is blue. So the most beautiful or the most lovable nickel is actually plus 2, nickel plus 2. Sorry for that. And then copper plus 1, copper plus 2. By the way, you could use also what you have learned when you were high school, copros, copric. You could use those terminologies. But I want you to be trained also with using copper plus 1, copper plus 2, so that you will not be hard up in the balancing of equation or in the forming of new compounds. So for copper plus 1, with oxygen, they are red in color. With sulfate, they are black in color. With chloride or other halides, they are white in color. In its non-binary form working with oxygen, it is black in color. Please take note of this. Cu2 and CuO, they vary in color. So if it is in this cuprous oxide, it is red in color. But if it is already in copper 2 or cupric oxide, it is black in color. In its sulfate form, blue, copper plus 2 with halides, green, with nitrates, copper plus 2 is blue. Okay, next topic, coordination compound. Okay, typically, sorry, typically, transition metal consists of complex ions and counter ions. So, anions or cations is needed to produce neutral compounds. That is the ruling that you have learned when you were in your grade school. So you need plus one and you need a negative one ions to produce a neutral compound. So that when you will have your redox, you know that uh, the cations and the anions are is still very active. Right. Number of bonds formed between the metal ion and the ligand complex ion. Uh, the most common is 6 plus 4 bonds. And for the case of the least common, the extreme, the 2 and the 8. Okay. Let's go to the a simple discussion of your ligands. Review your ligands when you were still in high school. A ligand could be a neutral molecule or ion having a lone pair that can be used to form a bond to a metal ion. So, based from your knowledge in grade school, you have the monodentate ligand, bidentate ligand, polydentate ligand. So, if the neutral molecule or ion with a lone pair electron is bonded with one, it is called monodentate ligand. One bond to a metal ion. Bidentate ligand, or also known as your chelate. Bidentate ligand, there are two bonds to a metal ion. Now, a ligand is a polydentate ligand if it has more than two bonds to a metal ion. Okay. There are let's go to an illustration of where ligands could be used. Ligands could be illustrated by the presence or by our alloys. And the most popular iron alloy, sorry, is actually your copper. Okay, brass. Brass, bronze, sterling, where is my pointer? Sterling, silver, gold, gold are all alloys of copper. So if we say 14 karat gold, it contains 12 to 28% copper plus 4 to 30 silver and 58% what is AU? Gold. So the most predominant is gold. So it is called gold alloy. Although you can see here that it contains other metals, which is copper and also likewise silver. So that is your 14 karat. But for the case of 18 karat gold, the gold content is higher. So the higher is the karat, the higher is the amount of gold, and the lower is the amount of copper. Sorry. The amount of silver depends upon the amount of copper that will be added. For the case of sterling silver, this is still used in some expensive ornaments or jewelries. It does not, of course, contain gold. So, 10 to 20 parts silver, 7.5 copper. And then you have here brass and the bronze. So, there are more copper for bronze than the case of a brass. But all of these are sometimes called as the copper. So if they are asking you what is that made up of, you better buy the bronze because it is more expensive because it has higher copper content as compared with brass. Okay, welcome to chemistry. These are your favorite features in chemistry. These similar familiar structures. I know you love them very much. That's why you enrolled in the BSE Science. Because if you hate them, I'm sure you are already in other field of specialization. So bidentate, the metal is bonded with two. Sorry. So between the two, this is the bidentate. It is bonded with two. This is monodentate. So the bidentate is this one, and this is the monodentate. So ethylene diamine. I'm sorry, but you have to learn as early as now simple biochemistry. Do not be irritated or do not be saddened with this formula because if when you will go to your next chemistry, organic chemistry, there you will be meeting a lot of ethylene containing compounds, a lot of alkene containing compounds. These are still simple, so wag muna kayong umiyak. This is ethylene is made up of carbon, no? Carbon and hydrogen. It is a type of hydrocarbon. So the ethylene here refers to this. Okay? This is actually double bond. So to make things simpler, you have here your carbon-carbon bond, the ethyl, CH3, CH3. Ay, sorry, not 3. Kasi it's ethylene. CH2, CH2. So you have here the ethylene and then the diamine 2. Diamine 2 amino group or ammonia group, ligand of um, ammonia. And this is a monodentate, ligand of ammonia. Okay? These are still examples of uh, illustration how active are your metals found in the transition group. This is your ethylene diamine tetraacetate. Never mind. If what you are thinking is, am I going to memorize the formula now? No. Just simply try to appreciate. If you want to appreciate, just simply be oriented that metal ions could bond with this kind of complex compound. So this could be already uh, structure to meet with another structure. Okay, roles for naming coordination compounds. Okay, this is an example of a simple pa lang yan roles for naming coordination compounds. First, always remember that the cation or the positively charged is named before the anion or the negatively charged. I think that is a cardinal role that you have learned in your grade school chemistry. So in this case, if this is the cation and this is the anion, chloride goes last. Okay. Number two, ligands are named before metal ion. So these are your, where's my pointer? Ligands. Okay. So your ligands are your amine and chlorine. And they are named supposed to be before metals. So do not start saying cobalt pentaamine chloride. That is wrong. The non-metal or the ligand should be the first to be named, and they are arranged alphabetically. So in this case, this is amine, this is chlorine. Amine has A, chlorine has C, so which will come first? The amine. But there is a thing that you should consider here. There are 5 amines. So in this case, you have to use your prefixes in your math. That is 2 is for di, 3 is tri, so 5 is penta. So there are 5 amines, so you could say pentaamine. And then there's also another rolling that you should follow. This should end with O. So we remove the prefix "-ine" and replace with O. So this will be pentaamine chloro. Oh, where's that? We are here now. I'm sorry for that. So we have here already the step. So if we're going to go back and continue our naming, the oxidation state 3 metal is designated by the Roman number 3. So you have here the one that we were already established as the start of the name, pentaamine for the 5, pentaamine, chloro, we have removed the "-ine" and replace it with O. And then the next now is the metal. So it is cobalt 3. Okay. So you have to write there the cobalt 3. So chloride. That is now your negative. So the name of this is pentaamine chlorocobalt chloride. It is alright if you're not going to write anymore the plus 3 or the other oxidation number. Pentaamine chlorocobalt chloride. What will determine whether this is plus 3 will be how how this is actually expressed, the ligand. Bring out your paper and pencil. Although this is not graded, please join the answering. Name the following coordination compound. So first, you should know where are the positive or the cation, right? And you should know what are the anions, okay? And then what are these? How do you name this? Cation. And how do you name this cation? And then for the case of an ion, what is the name of this? And what is the name of this? I'm giving you the freedom to use your periodic table to know the name. But when you will have your formal long exams, it will be closed periodic table. Okay, let's take letter A. I was able to get the answer. Okay, this is how to learn. How to learn is you try to analyze what are these. Okay. Bakit siya naging hexa aqua cobalt? Aqua for water. 6 water, cobalt. You might be thinking now, Mom, we were not told that aqua could be used for water. You could also use um, dihydrogen oxide, but the right term, the right way, the acceptable way in chemistry is to use the word aqua for water. Hexa for the 6, cobalt for the 3, okay, bromide for the Br. And then next, okay, there's no problem with sodium. All of you know what is sodium. Okay, you have here platinate and you have here chloride. So there are 4 chlorides. So di, ay mono, di, tri, tetra, penta. So 4 is tetra. So tetrachloro. This is tetrachloro. Chlorine is letter C. Platinum is P. So alphabetically, this should comes first. So you have the tetrachloro platinate. Do not include the tetra di as a part of your arranging it alphabetically. It is the elements. It is the element that is involved. So not the prefix. Okay? I hope you can follow. This will be our next topic, isomers within the transition metals. So from here, maybe you could have now your quiz from the beginning. But I would like you to finish first the transition metals before having the long quiz. But I will be giving a short quiz next meeting. Okay. So your first activity might be your quiz, and then we will continue the lecture on isomers within the transition metals. Okay. No assignment by now, but I would like to discuss with you in the laboratory some of the basic apparatus. So I hope that you have passed your assignments or your activity paper before. Have you submitted? I have not yet checked whether you have submitted or not. The deadline of the submission of your activity paper for basic apparatus used in chemistry is, may I assume, it today, Tuesday. Okay, so you are free to go to our Facebook chat if you have any question or you want something to be discussed further. Okay, but please, um, I assume that you are good with your periodic table. You know the different elements. You know the different valences. You could memorize the elements by period, what belongs to group 1 to group 2, or period 1 rather, period 2. You should be familiar. I am assuming that you are familiar with all of these things because your subject is inorganic chemistry. In the old curriculum, inorganic chemistry is the second chemistry. The first chemistry is the general chemistry. But because of the K to 12 program and the different tracks that you are into, the general chem was subsumed in your grade school curriculum. So I, as your teacher in a higher chem, now in your college, I assume that you have learned the basics in chemistry already. Okay, so I hope you are still fine. This is still introduction part of inorganic chemistry. We are not yet into the real inorganic chemistry. We are just simply introducing to you first the characters involved in inorganic chemistry. Kumbaga sa drama or sa skit, presentation of the different players or the actors of the show. So I repeat, from time to time, you should have with you your periodic table, your a sheet of paper, and your ball pen. Okay, thank you everyone again. I hope you are learning in our virtual discussion. Please go to your Google Classroom. I will be uploading this discussion.